How can you make predictions about a population from a sample? Think about this question during the lesson. The 2,468 registered voters in Adalia's town are voting on whether to build a new stadium. Adalia and her friends want the town to vote in favor of the stadium. How can they determine how the voters will vote before the day of the vote? How can you represent the problem situation? Adalia and her friends could ask every registered voter, or the entire population of voters in town, how they plan to vote. Is it reasonable for Adalia and her friends to survey every voter?
Select your answer.
Surveying thousands of people would take a very long time. Adalia and her friends would not be able to survey the entire population of voters. Adalia and her friends could ask a subset or a sample of the registered voters how they plan to vote. Surveying a sample of voters doesn't take as long and is more reasonable to do. Adalia and her friends would be able to ask 100 or 200 people. And although it won't tell them exactly how all of the voters will vote, a representative sample can give them a good idea of what to expect. When you're choosing a sample, why is it important for you to define the population as clearly as possible? It is not usually possible to study every member of a population, but if you know information about the members of the population, you can define and generate a representative sample.
Miguel thinks the science teachers in his school give more homework than the math teachers. He is researching the number of hours middle school students in his school spend doing math and science homework each night.
The blank includes all of the students in Miguel's school. A possible blank is some students from each of the grades in middle school. So we have to decide whether it's a population that they're discussing or a sample of that population. If the group includes everyone, that is going to be population. So we're going to write in that first blank space, population. And just a subset of those students would be a sample. So that is how we would complete these blanks.
Morgan decides to survey a sample of the town's voting population. How can she know that the survey results from the sample of voters represent the position of the entire town's population?
We're going to click on each sample to see more information. So sample 1, it says Morgan can survey a random sample or a randomly selected group of voters to make sure her results represent the position of the entire town. Sample 2, it says Morgan could survey a convenient sample of the first voter she finds. These results are not random and are not likely to represent the position of the entire town. Morgan could survey a randomly selected sample of voters. Because the size of the sample is very small, her results are less likely to represent the position of the entire town. So the question is, how can she know that the survey results from the sample of the voters represents the position of the entire town? The best options to make sure she is reflecting the entire town's position would be to either take a random sample or a randomly selected group of voters to make sure that they are reflecting the views of that particular group of people.
A produce manager is deciding whether there is customer demand for expanding the organic food section of her store. How could she obtain the information she needs?
She could obtain a random sample of shoppers. So she could ask random people in the store how they would feel about expanding to that organic food section and get their results. And that could create a representative sample for her that will represent the thoughts of most of the people in that area or town or population.
A town will soon be voting on building a recycling center. Out of a random sample of 250 voters, it was found that 165 voters are in favor of building the recycling center. Part A. Out of a total of 55,000 voters, how many do you predict will vote in favor of the recycling center?
We would write and solve a proportion to predict the number of voters in favor of the recycling center. So you would take the number surveyed in favor of the recycling center over the total number of people surveyed, and that proportion would be equal to the total number of people in favor and the total number of voters. So the total number of people surveyed was 250 voters, and the number of people who were in favor of the recycling center was 165. So we take and say the total number of voters found here is 55,000 voters. So we take the 165 over 250 and multiply that by 55,000 because we want to get our variable V, which are the voters who are in favor of the recycling center. We want to find that value, so we have to do the inverse or opposite of division and multiply. So we multiply the 165 times the 55,000, and then we will get 36,300 people in favor of, predicted people will vote in favor of the recycling center.
A town will soon be voting on building a recycling center. Out of a random sample of 250 voters, it was found that 165 voters are in favor of building the recycling center. Part B. The table gives the actual results of the vote. Why is the predicted number of voters in favor different than the actual number?
The random sample is a subset or just a part of the entire voter population. So the actual results may be higher or may be lower. It's just a prediction. It's not going to be an actual amount. So your actual amount may be different from the estimated or predicted amount of people in favor.
Out of a total of 55,000 voters, it is predicted that 36,300 voters are in favor of the recycling center. The table gives the actual results of the vote. How many voters are predicted to vote against building the recycling center? How does this compare to the final voter results?
The question, how many voters are predicted to vote against the building the recycling center, is the first part of this two-part question or problem. So first we have to go back to the example, and it tells us that there were 165 voters in favor of the center, and there was 250 total. So we're going to take the 250 total people in that sample that voted, and we're going to subtract it from the 165 people that were in favor of the center, and that's going to be 85. So those 85 people are the ones who did not want this recycling center. So now we take the 85 and create our proportion out of the number of voters, and that's 250. And then we're going to multiply that by the total number of voters in that population, and that's going to equal our predicted amount of people who are not in favor, and that's going to be 18,700 people not in favor of this recycling center. And the second part of this is, how does this compare to the final vote? So the final was 22,700. So our prediction is a bit lower than the actual votes.
Derek is writing a report on cell phone usage. He collects data from a random sample of 7th graders in his school and finds that 16 out of 20 7th graders have cell phones. If there are 290 7th graders in his school, estimate the number of 7th graders that have cell phones.
We're going to write and solve a proportion to estimate the number of 7th graders. C, so C is representing those 7th graders that have cell phones. So 7th graders with cell phones in the sample group, and then the number of 7th graders in that sample. That's going to be equivalent to the 7th graders with cell phones in the school and the number of total 7th graders in the school. So the predicted amount or sample amount was 16 out of 20 have cell phones. So the total number is 20 in that sample, and 16 have a cell phone. The total number of students in the school, we don't know, but there are a total of 290 7th graders at this school. So now we take the 16 over 20 and multiply that by the 290 so that we can find the value of C. And then the value of the number of students in 7th grade with a cell phone is 232 students based on that sample in Derek's school. For his report, Derek also collects data from a random sample of 8th graders in his school and finds that 18 out of 20 8th graders have cell phones. If there are 310 8th graders in his school, estimate the number of 8th graders that have cell phones. So we're going to follow the exact same steps as we did for the 7th graders. So we have 18 8th graders out of 20 in that sample. And then we have 310 8th graders, and we're going to use that same variable C to represent the 8th graders in that school with a cell phone. The next step is to multiply the 18 over 20 times the 310, and that will give us the value of C, which is the number of students with a cell phone in 8th grade, and the total of students with cell phones in 8th grade is 279 students.
The table shows the numbers of monthly cell phone batteries manufactured at 2 companies last month. Defective batteries did not charge properly. Out of 15,000 new batteries manufactured by each company next month, which company will expect to produce fewer defects?
Write and solve 2 proportions showing the number of defective batteries out of 15,000 produced. So company A manufactured 11,500, 75 were defective. Company B had 12,225, 90 were defective. For company A, you do 75 defective batteries over the total number of batteries, and you're going to multiply that by 15,000 new batteries, and then you're going to get approximately, that squiggly equal sign means approximately, so there's going to be approximately 98 of the batteries that will have defects. Company B, you're going to do the same. You put the number of defective over the number produced. You're going to multiply by that 15,000 and approximately 110 for company B. In conclusion, company A is expected to produce or manufacture fewer defective batteries than company B next month.
Company C had 60 defective batteries out of 10,800. If Company C also manufactures 15,000 new batteries next month, how does this company compare to the others? Explain.
Following the steps from the example, we're going to take the 60 defective batteries and put it over the total manufactured, which was 10,800. And then we're going to multiply by the 15,000 new batteries. And that is going to equal approximately, let me do that squiggly equal sign, approximately 83 defective batteries. And it says, how does this compare? Well, Company C will have more than company, it's going to have less than company company A, but it is going to have, it's going to have less than both. So Company C would actually have the least number of defective batteries.